So in this lesson, we're going to determine how much you need to invest now to reach a certain financial goal in the future. So this is opposite of what we were doing in the last lesson. In the last lesson, we were learning, based on what we're depositing now, what it's going to be worth in the future. For this lesson, we have a goal in mind for the future, but we need to know how much to invest now to reach that goal. Okay? And just like before, there is a formula. And it's this formula right here. And it's the same variables that we were using before. B is the ending balance. Okay. This was the formula. Well, this is the formula to find out what we need to start now to end up with a particular ending balance. So B is the ending balance, P is the principal or the original balance, like we talked about. Here's that formula again that we saw in compound interest, 1 plus R over N to the NT power. So this problem says Mr. and Mrs. Johnson know that in 6 years their daughter Ann will attend state college. She's going to need $20,000 for the first year's tuition. How much should the Johnsons deposit into an account that yields 5% compounded annually in order to have that amount, in order to reach $20,000? So that is their goal, and the question is, how much do they need to put in now to get $20,000 in 6 years? Well, here's the formula. So we're going to put $20,000 in for B. So B is going to be $20,000. That's their ending balance, what they want. P is what's unknown. R is their rate. We know that it was 5%. Number of times interest is compounded annually. That was the end value again. This is compounded annually, so it's only 1. Number of years was 6 years. So we're just going to substitute those numbers into the formula where they go. And again, just let your calculator do the work. So we're going to have 20,000 on top, 1 plus the rate divided by N, which is the number of times it compounds annually, times N times T, which is 1 times 6. So we've got this big fraction here that we just need to simplify. So we need to figure out what this number here is on the bottom. So again, same thing, 0.05 divided by 1. So we'll do 0.05 divided by 1 plus 1. And we're going to raise that to the 6th power. Gives us this decimal here. Now I do 20,000 divided by this number. So I'm going to do 20,000, and for this I'm going to have to write this number down. 1.34009. That's probably enough. 20,000 divided by 1.34009 gives us, well, I didn't take it up. Yep, $14,924.37, and they come up with 31 cents because I rounded too soon. But plug the numbers into the formula, let your calculator do the work. How many years would it take $10,000 to grow to $20,000 in the same account? So this is our ending balance. This is our original amount. You know what? We're going to skip that one because that one's finding T, and we're not going to have any problems like that. So I'm going to go on to this example here. Ritika just graduated from college. She wants $100,000 in her savings account after 10 years. How much must she deposit in the account now at 3.8% compounded daily in order to meet that goal? So remember the formula was what she needs to put in now is equal to her ending balance, what she wants it to be, divided by 1 plus R over N, all to the NT power. Well, the beginning balance is 100,000. 1 plus the rate was 3.8, so 0.038 all over n, which is the number of times it compounds in a year, which for this one's going to be 365, and all of this is to the 365 n times t, which is 10 years. So big numbers, but you just let your calculator do the work. So I'm going to divide here, so 0.038 divided by 365 plus 1. So there's this number. And now 365 times 10, that's 3,650. So I'm going to raise this to the 3,650 power, and my calculator does the calculation for me. So this would be, I'm going to need to write this number down because I'm going to have to put in the 100,000. Divided by 1.462255673. So now I'm going to let my calculator do this work right here. And the answer is $68,387.49. So the current amount she needs to put in to reach $100,000 in 10 years at 3.8% is $68,387.49. Present value in order to reach a desired or a goal in the future. That's it.